So a Norman window is a popular construction in calculus and pre-calculus classes because it looks like the following. You start with a circle, and then you get rid of half of the circle, and then you pop a square or a rectangle on the bottom like this, and there you've got yourself a Norman window. Okay, there you go. There's your Norman window. So now we read. A Norman window is a window constructed by adjoining a semicircle on top of an ordinary rectangle. Draw a Norman window having a width of x and a rectangular height of y. So the width is x and the height is rectangular height is y, meaning this part is y. Okay, then we know automatically that the radius of this circle is x over 2. Write the area as a function of x and y. Okay, so the area is, this part is x times y, and the top is pi r squared is the area of a circle, but it's half of that, so it's pi and then r squared all over 2, right? We put all those pieces together, xy plus pi over 2 x over 2 squared, which is xy plus pi over 8 x squared. Right, the perimeter is a function of x and y. Well, what do we have? X and y, and what is, so this is y, x, and y, and then the perimeter of a circle is 2 pi r, right? But we only have one of them, so it's pi times r is for this. I'm sorry, you don't usually have colored pencils for your exams, I guess. But if you want to bring them, you're welcome to. Well, you get x plus 2y plus pi x over 2. And you may say, wow, that's a lot to remember. But it's not, because it's the same. Like if I give you a different Norman window, I can't really change it by much. So sometimes in mathematics classes, the more complicated a problem looks, the easier it is, because, well, it looks complicated on the page. I can't change it. If I give you one of them, it would have to be pretty much identical. So it's just a matter of studying it. Okay, so the Norman window has a perimeter of 32 feet. Solve for y in terms of x. Okay, so the perimeter is 32, is x plus 2y plus pi x over 2, and it says solve for y in terms of x. Okay, so that means the 32 goes over there and the 2y goes over there, and you get minus 2y is x plus pi x over 2 minus 32. And then I guess you divide by negative 2. So flip all those signs. Okay, and then you divide off everything by 2. That's a mess, but technically you've done it. Let's just rewrite it to be a little nicer. Minus 1/2 x minus pi x over 4 plus 16. Okay, so now I want to use my newly found expression. Let me just move this over, squish it a little. Go. I'm going to now use my new expression for y in terms of x and rewrite the area as a function of x alone. So I have a is equal to, I'm going to use this piece right over here, x times y, leave a lot of space, plus pi over 8x squared. And the y in here is 16 minus x over 2. I can feel free to rearrange the pieces as long as it's equivalent. I just don't like all those negatives. So if I start with a 16, it saves, well, it doesn't save me a negative, but I don't need to put the plus then. Okay, so that is technically correct, but we are going to have to maximize this. So we should just continue while we're ahead here. A is equal to 16x, let's just distribute this x here, minus x squared over 2 minus pi x squared over 4 plus pi over 8x squared. Okay, so A is equal to, everything has an x in it, and some things have x squared in it. So let's collect up the x squared terms. We have 3 of them. Okay, so some of them have pi's in them, some of them don't. Here's an x squared, it has a minus 1/2. Then we have pi over 8 and minus pi over 4, and together that will give us a negative pi over 8. Or you could write it out slowly. And we still have the 16x. I wanted to group it this way because I wanted to show you that we can find the vertex using minus b over 2a. Okay, because a parabola, this is going to be a max or a min problem. And if it's going to ask us maximize the area, or it's going to ask us to minimize the perimeter, those are the only 2 ways this particular problem can work in a pre-calculus class. Either way, you're still finding the vertex of a parabola. So this is A and B. Vertex is at minus b over 2a. So let's continue. So x equals minus b over, these are all still going to be negatives, but I'm going to multiply that by 2. Minus pi over 4. Okay. So that looks awful, but you know what? There's all those negatives, so we can just multiply top and bottom by -1. Make this a little bit nicer. Okay, so again, we can make this even nicer. We can multiply top and bottom by 4 if we want to. It's not necessary, but if it makes you happy, let's do it. If it doesn't make you happy, you can leave it the way it was.